Welcome back. Now, as we have said, we're going to be moving on to our application questions. And remember, they are still based on the visible light. So now we are supposed to study the diagram that is alongside and then answer the questions that follow, obviously. So the question is, what happens when you move closer or further away from an object? So remember, when you're moving closer to an object, that object will appear bigger and bigger and bigger. But if you move away from an object, the object is going to appear smaller and smaller and smaller. So why is that happening? It is because of the light that is being reflected off the object. So what happens when you move closer? When you move closer, the object will get bigger in size and when you move away, from the object, it will get smaller in size. So if you move closer to the object, it will appear bigger and bigger, and if you move away from an object, it will appear smaller and smaller because of the light that is reflected there. So this question says we need to differentiate between luminous objects and illuminated object. So luminous, we need to differentiate between luminous and illuminated. What is the difference? Remember, luminous objects, those are now objects that emit or that produce light. So any object that can produce light or any object that can emit light is said to be a luminous object. Now, an illuminated object, that's now an object that can reflect light. So any object that we can be able to see because of light, that object is going to be an illuminated object because that object was lit up by the light. If it's lit up, it's illuminated. So therefore, any object that can reflect light, because light coming from the source goes into the object, bounces off the surface. That bouncing back of light, that's what is called a reflection. That bouncing back of light from an object is a reflection. And when that light bounces off the object, it goes into your eyes. And because it goes into your eyes, you can be able to see the object. So then that means that object has reflected the light or that object has been illuminated. So an object that can reflect light rays, so any object that can be able to reflect light rays is known to be an illuminated object. And if an object is able to emit or able to produce the light, that object is said to be a luminous object. Now, next question. We are supposed to arrange colors of visible spectrum in order of increasing frequency. Remember our colors, our 7 colors of visible spectrum. We have Rooikweight, We know that as you are moving from red to violet, the wavelength of those colors is decreasing. And if the wavelength is decreasing, it then means that the frequency is increasing. So to write there, let's just write ROIC B, or let's just write them in full: red, orange, yellow, green, blue, indigo, and violet. So we are saying that as you are moving from red to violet, wavelength increases, or wavelength decreases. As you're moving from red to violet, wavelength decreases. Remember, wavelength is measured from peak to peak of 2 consecutive waves. So wavelength decreases, and because of that, the frequency is going to be increasing. So therefore, frequency is increasing. So now, arrange the colors of visible spectrum in order of increasing frequency. So that means the first one is going to be red, number 2 is going to be orange, number 3 is yellow, followed by green, and thereafter blue, followed by indigo, and then the last one is going to be violet. So arrange the colors in order of increasing frequency. That means violet has the highest frequency as compared to all the other ones, as compared to red, orange, yellow, and all the other ones. However, red will have the highest or the longest wavelength as compared to all the other ones. So if it has the longest wavelength, remember, frequency is going to be very small or going to be very short. So as you're going from red to violet, we are decreasing in wavelength and increasing in frequency. But as you are moving from violet to red, we are going to be increasing in wavelength, and therefore we're going to be decreasing in frequency. So that's that relationship between wavelength and frequency, that when the wavelength measured in lambda increases, the frequency is going to be decreasing. So now, the other question, or the last question given to us, says, what is the speed of light? Remember, we can measure the speed of light in terms of kilometers or in terms of meters. We do know that it takes 8 minutes for light to travel, for one light ray to travel from the source, being the sun, into the earth. So it takes 8 minutes. So if something was to happen to the sun right now, if something was to disappear, if the sun was to disappear, you'd only realize that the sun has disappeared after 8 minutes. Because it takes 8 minutes for the sun rays to move from the sun into the earth. So after those sun rays have reached the earth, and then there's nothing else coming in after that, you will see that the sun has disappeared. You'd think that it has disappeared only then, but it would have disappeared 8 minutes before you saw it. So what is the speed of light? The speed of light, we can measure the speed of light in terms of kilometers. We do know that is 300,000. 300,000 kilometers per second. Or this is going to be 3 times 10 to the exponent of 8 meters per second. So we can either measure the speed of light in kilometers or measure the speed of light in meters. So it can either write either or, between 300,000 kilometers per second or 3 times 10 to the exponent of 8 meters per second. So before we move on, learners, we're just going to quickly go for an ad break, and I will see you just after this.